In this video, we're going to go over just a few things that you need to make sure you understand before your test tomorrow. I'm going to try to go fast so we don't have a lengthy video, so I won't be going over everything or even finishing every problem. So it says, tell whether the ordered pair is a solution to the system. Remember, a system is two equations, and this ordered pair has to work for both. So I plug them in. And so for this first equation here, I have -3 minus 3 times -4 equals 9. And I'm going to simplify this, and here we'll get a positive 12. And this has to make both work. And so this is true. So then I need to check the other one. If it is true, I say yes, this is a solution because it makes both equations true. If it doesn't work for the second one, then I'll say no because it doesn't make both of them true. So it needs to make both. So again, I didn't finish this one. I just want to make sure you know how to do it. So number 2, solve it by graphing. When we graph, we really want them to be in y equals mx plus b. Okay, this guy he has a y-intercept of -9. His slope is -3/1. So I'm going to go down 3/1. And if you can't really fit that on the graph, then do it backwards. Go up 3 and backwards 1. So here, up 3, backwards 1. Up 3, backwards 1. Up 3, backwards 1. Just make sure that if your slope is negative, your line is going down as you read it left to right. So we'll have a line that looks like that. Okay? And then the second one here, we need to get y by itself. Remember, kind of make a template for yourself. We need this to look like y equals mx plus b. So on this side, all we want is y. We want a number and an x on the right-hand side. So we're going to take this guy to the other side. We're going to add 2x to both sides. And so we'll get 2y equals 2x plus 14. Finally, then, we're going to divide every single thing by 2. And we see that y equals x plus 7. So we're going to graph that guy also. And his slope is 1/1. So make sure that he's going up. And then finally, you need to give the point of intersection where they cross. So once you graph it, you're going to see where they cross, and you're going to give this point of intersection. They should always cross. If they don't, they're going to be parallel, in which case they will have the same slope. So you can see in this case, they definitely will not be parallel. So we definitely will have an ordered pair as our solution, and you can look on the answer key to check to make sure that you have the right solution. Number 5, it says solving by substitution. So when we see this, we think of plugging in. So we need something to plug in. We need it to look like x equals something or y equals something. And you can see here we don't have that situation at all. So we need to solve for a variable. We need to pick one of these variables to get by itself. And hopefully you notice that this is the simplest one. There's no number there, so that's what we're going to get by itself. So if I'm trying to get x by itself, I need to make sure that I get rid of this 4y. So I'm going to add 4y to both sides. And we get x equals 4y minus 9. Now, it looks like x equals, and that's what we wanted. And x is equal to everything in this box. So because it's equal to x, I'm going to plug that in for x in the other equation. So I'm going to rewrite this equation. Except instead of using x, I'm going to use what's in that box, and then I rewrite the entire rest of the equation. So here, I'm going to plug in 4y minus 9, because again, this is supposed to be x, but I know that x is equivalent to everything in that box. Now, I can simplify. So I'm going to distribute. I get 12y minus 27 plus 5y equals -27. Finally, I'm going to combine like terms. 17y minus 27 equals -27. If I continue, I see here that they both cancel. That's okay. I'm allowed to have nothing left over here. I just can't leave it blank. So remember, nothing left means 0. And I'm still getting y by itself. I have a solution because my variable is still there. So I divide both sides by 17. And 0 divided by a number is always 0. Remember, for each of these, my answer has to look like an ordered pair. I found y. I need to go back now and find x. So I come back up here to either one of my original equations or this new one that I came up with. If you drew that box, that's always probably going to be the one you're going to plug it into. So I'm going to plug it in right there. So x equals 4 times 0, because I know that y is now 0, minus 9, or 0 minus 9, and I get negative 9. Okay, number 7 says solve by elimination. Elimination, something should eliminate. So if we were to add these together, you can see here that 3 minus 6 is negative 3x. Negative 6 and positive 6 is why those get eliminated. And negative 24 plus 18 is going to give me negative 6. From here, I'm going to solve. I'm going to get x by itself, and then I'm going to plug it back in to find the y value. When we get to number 8, we see that we don't have something that's going to cancel. So we need to force them to be opposite coefficients. And these are already really, really close to canceling. I just need one of them to be positive. So I'm going to multiply by negative 1. I'm going to choose maybe, I don't know, this guy right here to multiply by negative 1 so that we get negative 3x plus y equals positive 5. Remember, I distribute that to all three. Once I have that, I'm going to bring down this equation. And now I'm solving this system. Okay? So remember, these two equations are exactly the same. So I can use this new one instead. And I'm going to add them together. Here, remember, there's a 1. So negative 3 plus 1x is negative 2x. Y minus y cancels. It gets eliminated. That's what I wanted. And 5 and 13 make 18. From here, I solve for the remaining variable. And finally, to get the value of y, I plug that back into either of my original equations. So if I look up here, I would probably choose this one. It doesn't matter. But when we plug in x, we'll get negative 9 minus y equals 13. Just remember there is a negative 1 here. So you will get y by itself so that you can write your answer as an ordered pair. If we have an inequality, remember we're looking for those words that indicate inequality. So if you read this, hopefully you already did, it says that we're buying money for a salad. And a lot of times it uses words like at least, at most. Here it just says write an inequality. So we need to think about what we are doing here. And here we're spending money. Remember, you cannot spend more than what you have. Here we have $14, so we can spend less than that, or we can spend all of it. And then we're just kind of filling in the pieces. So it says we have $2 per pound of apples. So I'm going to use A to represent the pounds of apples. Okay, and then I'm going to use B to represent the pounds of bananas. And I'm going to set up an inequality. So I know that apples are $2 per pound. I know bananas are $1 per pound. And there's my inequality. Here I can get either variable by itself because they're A's and B's, they're not X's and Y's. So I'm going to pick this guy. So I'm going to subtract 2A. So I have 1B is less than or equal to negative 2A plus 14. And this is already kind of in y equals mx plus b form. So if I graph it, and I don't need negative numbers, because remember we're talking about pounds of apples and pounds of bananas. Here I'm using b as my y value. So this guy represents my pounds of bananas. And this guy represents my pounds of apples. And I'm going to start with my y-intercept, which is 14. I'm going to go down 2 over 1. So down 2 over 1, down 2 over 1. And you would continue. And I'm going to have a solid line. And I'm going to shade everything below because it says B is smaller. So I'm shading everything in that region. And then the question says, give 2 possible combinations of pounds of apples and pounds of bananas that Tony can buy. So just make sure you're picking any 2 points here in the shaded region and describe how many apples that would be and how many pounds of bananas that would be. Same thing with the other ordered pair. Okay. Finally, when we graph a system of linear inequalities, our final answer is in the shaded overlapped area. So if we graph both of these, we'll get something that looks like this. And so hopefully you get something like this, and hopefully you remember that my final answer is where my shading overlaps, and that's going to be in this area here. So that's going to be my final answer. Just make sure you answer the rest of the question. We're going to give 2 ordered pairs that are solutions and 2 that are not. And we need a label so that I know which ones are and which ones are not. So for my solutions, you're going to pick any 2 ordered pairs that are in this darkened area. And then anything that is not a solution, you're going to give 2 ordered pairs anywhere that's not in that darkened area. It can be in this yellowish area, it could be in this pinkish area, or in the completely blank area. So good luck on your test. I hope you do really well, and I'll see you after Thanksgiving break. Have a great break, everybody.